These are the lesson 2-4 notes on linear models. Today we're going to find linear models, use them to make predictions. We're going to practice writing some linear equations out, and we'll also use linear models that pass through the origin. We're going to take a look at this first problem. It says in 2 hours, a worker will be 185 miles from home. In 4 hours, the worker will be 95 miles from home. How far will the worker be from home in 5 hours? What we're going to do is we're going to come up with an equation for a line that models this data, and then we're going to use the equation for the line to substitute in 5 hours and answer the question. So the first thing we're going to start with are the two pieces of information we're given. It says in 2 hours, a worker will be 185 miles from home. If you want to, you could kind of think of 2 as being like an x coordinate. It's a time measurement. A lot of times time is an x value. And we'll lose this distance of 185 miles as the y coordinate. So this first sentence you could think of as being a point, 2, 185. In the same fashion, in 4 hours, a worker will be 95 miles from home. You could think of that as the point 4, 95. And if you're going to make an equation that's based off of 2 points, typically the best model to use when you're given 2 points is something that's called point-slope form. Now the point-slope form of a line is this equation that goes y minus y sub 1 equals m times x minus x sub 1. And you may recall that m refers to the slope of the line, and x1 and y1 are the coordinates of one of the points on the line. Now to find the equation for our line, one thing that we have to calculate is the slope. So up here in this empty space here, I just want to reacquaint you with the formula to find slope. To calculate slope, you can take the difference of the two y coordinates over the difference of the two x coordinates. And it doesn't matter what order you subtract the y coordinates in, as long as you subtract the x coordinates in the same order. I'm going to take 185 minus 95. I'm going to subtract the points in that order. Those are the two y coordinates of the points that we have. And then when we divide the x coordinates, we need to take the x coordinates in the same order. So I can't do 4 minus 2 because I wrote 185 first. So that's sort of like my y2 value. It corresponds with an x2 value of 2. So x2 has to be 2. So we're going to calculate 185 minus 95 over 2 minus 4. When you subtract the two numbers up top, what you get is 90. In the denominator, you get negative 2. And if you take 90 and divide it by negative 2, you get negative 45. That is our slope. And that's really the hard part of the problem. For the rest of the problem, all we're going to do is we're going to plug the y and the x in here as they're originally mentioned. x1 and y1 are the coordinates of one of the points of our line. Now if you want to stay consistent and use the 4 and the 95, which we called x1 and y sub 1 over here, that's fine. So if you want to go, hey, x1, we're going to call that 4, and y1, we're going to call that 95, you can do that. It actually doesn't matter, though, if you want to use the 4 and 95 or if you want to use the 2 and the 185. So an alternative equation would be y minus 185 equals negative 45 times x minus 2. Now we're going to use this model that we just came up with to answer the question. The question is, how far will the worker be from home in 5 hours? This is an equation that you can solve to answer the question. Now 5 is an hour measurement. For the hour measurements, that's been our x coordinates. We're going to substitute 5 in place of the x in this equation. So we're going to solve this equation, y minus 95. And we're going to substitute the 5 for 5 hours in for x. Now to solve this out, we can do the work in parentheses. Obviously 5 minus 4 is equal to 1. So this is negative 45 times 1. That's just negative 45. So to solve this problem, we just have to solve this equation. Y minus 95 equals negative 45. I've multiplied it by 1 already. It's just equal to negative 45. To get y by itself, you can add 95 to both sides of the equation. And negative 45 plus 95 is equal to 50. And that's the solution we're looking for. This point-slope form is valuable. Anytime you have 2 points, it's relatively easy to find the equation of a line using our point-slope form. And in each of these examples, although the questions look kind of different, all of these questions can be answered using point-slope form and pretty quickly. In number 1, we're given 2 points, 2, 5 and 6, 1. To find the equation of the line, the first thing you want to calculate is the slope. We do that by subtracting the two y coordinates. It doesn't matter what order. I'm just going to go 5 minus 1. and then we're going to subtract the two x coordinates in the same order. When you divide, you're going to get 4 over negative 4. When you divide these two, obviously that's equal to negative 1. And when you write your equation, you're going to go y minus, if I use y1 as being the number 1, and then I'm going to go my slope m times x minus x sub 1. Because I used 1 as my y sub 1, x sub 1 would be 6. Now this is one equation that you could set up. You could alternatively use y minus 5 equals negative 1 times x minus 2. What about these other problems? Well, if you're given a point like 2, 5 and it has an x-intercept of 4, the x-intercept of 4 means we're looking for the point that's located 4 units along the x-axis at 4, 0. So similar to number 1, you could solve this equation by finding the slope between these 2 points and coming up with the equation for the line. If it's a y-intercept of 7, the y-intercept is up 7 units on the y-axis, that would be equivalent to the point 0, 7. And now you've got 2 points, you could find the slope, plug in a point, and use point slope form. If you have an x-intercept of 4 and a y-intercept of 7, that's just merely the points 4, 0 and 0, 7. Find the slope between the points, plug in one of the coordinates, and then you've got your point slope form. What I'd like you to do is see if you could come up with the equations for numbers 2, 3, and 4 by first calculating the slope between those 2 points and then plugging in one of the point's coordinates and using point slope form to come up with an equation similar to what we did on number 1. Go ahead and pause the video, crunch this out, and we'll see what you came up with in just a moment. All right, so for problem number 2, we're calculating the slope first. Our slope right here is equal to negative 5 halves. When you write your equation, there are 2 options depending on what you use for x1 and y1. You could write y minus 5 equals negative 5 halves times x minus 2, or y minus 0 equals negative 5 halves times x minus 4. Because it says y minus 0, that's just y. So really, if you wrote y equals negative 5 halves parentheses x minus 4, that'd be fine also. For number 3, we calculate the slope right here. The slope is equal to 2 over negative 2 or negative 1. So when you write your equation, again, 2 options. You can either say y minus 5 equals negative 1 parentheses x minus 2, or y minus 7 equals negative 1 parentheses x minus 0. Again, x minus 0 is the same thing as x. So if you said y minus 7 equals negative 1x without the parentheses, that's fine. On number 4, when you calculate the slope, you get negative 7/4. If you wrote that as a decimal, that's equal to negative 1.75. Similarly, on number 2, if you said negative 2.5 was the slope, that's fine. When you write your equation, 2 options, y minus 0 equals negative 7/4 x minus 4, or y minus 7 equals negative 7/4 x minus 0. Again, if you see y minus 0, you could just say y. If you see x minus 0, you can just say x. So we'll put this all together one last time. We're going to take a look at 5. It says if it takes 3 hours to travel 175 miles, how long will it take to travel 300 miles? This is a problem where we're going to assume that our model passes through the origin. That's the point 0, 0. So in this case, what does the origin represent? Well, if we think of 3, 175 as being our ordered pair, again, time is our x variable, and our distance, 175 miles, is our y coordinate. The origin, which is the point 0, 0, represents the same units. So 0 represents hours. It also represents miles. We could say at 0 hours, or at the present time, we've gone 0 miles. And assuming that this is one of the points that we're working with, we now have 2 points, and we could come up with a point slope form equation. First thing we're going to calculate again is the slope. To calculate the slope, y2 minus y1 over x2 minus x1. In this case, it's pretty nice because it's 175 minus 0 over 3 minus 0. If you'd like to leave your slope as the fraction 175 over 3, that's appropriate. If you want to convert it to a decimal, okay. When you come up with your point slope form equation, there are 2 options. If you want to use the point 3, 175, it's going to look like y minus 175 equals our slope, 175 thirds, over x minus 3. Now if we use the other point, it's kind of strange. What we get is we get y minus 0 equals 175 thirds times x minus 0. And what happens is if you actually simplify this, what you get is you get y equals 175 thirds x. And that's kind of handy because if you're given the slope-intercept form of the equation, this is an equation in the form y equals mx plus b. If you use the zeros here, the zeros actually cancel, and what you get is y minus 0, which is just y, equals 175 thirds. X minus 0 is just x, so this is 175 thirds times x. And if I suppose if you want to distribute this across the 0, you could do that. So you could say plus 0 or minus 0, but honestly, I think it just makes more sense to say the equation is 175 thirds times x, and that's what y equals. It says solve one of the equations to answer the question. We want to know how long it takes to travel 300 miles. Remember, miles is your y value. Time is your x value. Distance here is your y value. So 300 miles is going to get plugged in for y. You can use the point slope form, the equation that we came up with in either of these locations here. I think the easiest thing to do is plug it into this last equation because there's kind of the fewest number of things here. So we're going to plug in 300 for y. And it's equal to 175 thirds times x. Now you know usually to figure out what x is equal to, we divide by the coefficient. So you could divide by 175 thirds. It's actually the same thing as multiplying by 3 over 175. We'll show you how that works on your calculator. If I were to actually take the number 300 and then divide it by the fraction 175 over 3, we get this decimal 5.14. Now, like I said before, you could also take 300 and multiply it by the reciprocal, 3 over 175, and you'll get the same thing. That's what your x equals, and that's the answer to the question. X equals approximately 5.14. Your units are going to be hours because that's what x represents. And we've used our linear model to answer this question.